Welcome to video 5.7c, using markings on figures to name the quadrilateral. All right, so here's example 3. Use the markings on the figures to give the most descriptive name for each quadrilateral. Okay, so I personally think these problems are fun. I hope you do as well. All right, so we're definitely going to be using kind of our definitions, our properties, ways to prove things are quadrilaterals. All right, so first thing I want to point out is everything appears to look kind of like a square. You can't go based on appearance. You've got to go based on markings. So here's an example. This appears to be a square. However, let me show you the analysis. We've got parallels here. So just based on exactly one opposite sides being parallel, we know we're a trapezoid. So one pair of opposite sides parallel gets me to be a trapezoid. Then I've got the non-parallel sides congruent. Non-parallel sides congruent. That gets me to an isosceles trapezoid. And here's an example of what it could look like. Here's a pair of parallel sides, and I made sure that this, and this each measured 4 inches. They're all congruent. And clearly you can see it's an isosceles trapezoid and not a square. Okay, part B. So let's just go through our analysis. Let's try to see if it's a parallelogram. Well, the diagonals bisect each other. So diagonals bisect each other. So we know we're a parallelogram. The diagonals are congruent. Double tick plus double tick is the same as double tick plus double tick. So diagonals congruent, that gets me to a rectangle. The diagonals are perpendicular. That's going to get me to a rhombus. And then if we're a rectangle and a rhombus, of course we're a square. Rectangle plus rhombus gets us to be a square. So I encourage you to pause the video and try these on your own, but I'll go through the rest right now. All right, over here, we've got one pair of opposite sides that are both parallel and congruent. That's a way to get a parallelogram. So one pair of opposite sides, both parallel and congruent, that gets us to be a parallelogram. Okay, moving on to part D. Over here, they gave us a transversal with these angles being congruent. So I'm going to go back to the transversals lesson. I'm going to extend these lines here, extend these lines here. This angle includes that side and that side, this side and that side. So the thing in common is a transversal. The other two things must be parallel. Okay, so now I've got one pair of opposite sides parallel, and again, the non-parallel sides congruent. That's just like over here, the isosceles trapezoid. So again, one pair of opposite sides parallel, that gets me to be a trapezoid. Non-parallel sides congruent, that gets me to be an isosceles trapezoid. All right, over here, they just gave me numbers. You're congruent to you, and you're congruent to you. So I've got a quadrilateral with both pairs of opposite sides congruent. Again, that's enough to be a parallelogram. Both pairs of opposite sides congruent, that gets me to be a parallelogram. Okay, this last one. I've got one pair of opposite sides, both parallel and congruent. That's a parallelogram. One pair of opposite sides both parallel and congruent. That gets me to be a parallelogram. I wish that word wasn't so long. However, I've got more information. I've also got one right angle. So if I'm a parallelogram with one right angle, I'm also a rectangle. So with one right angle, that gets me to be a rectangle. So there you have it, how to use markings on diagrams to come up with the most descriptive name for quadrilaterals.